Velocity of body moving in viscous medium. Now here we are having the two cases. First, when the body moves vertically downward, and second, when the body moves horizontally in the viscous medium. So there are two cases. Number one, velocity of body falling vertically downward in medium, and second, velocity of body moving horizontally in medium. So we will take the case one by one. First we are taking when the body is falling vertically downward in the viscous medium. So now case 1. The velocity of body falling vertically downward in viscous medium. There are so many examples of this kind. Examples are falling of asteroids, meteors, raindrops, ice balls, snow fall, dewdrops, etc. There are so many examples of this kind when the body falls in the viscous medium. The viscous medium may be the air or it may be the liquid. However, we will discuss here only about when the body is moving in the liquid. So this is the body. This body is falling vertically downward. This is the weight of the object falling like this. Here we have the drag force Fd. This is the medium in which the object is falling. This is the medium. So this is the body. This is medium. So the weight of the body. drag force Fd is equal to 6 pi eta r V. So we can write it to be now BV, where this B is equal to 6 pi eta r. This V is the velocity of the object. Now weight. Weight of body. This is equal to mg. M the mass of the body, where m equal to mass of. Here the different terms have their usual meaning, as I have told you earlier also so many times. So now this now for so much, so now net force will be how much? Net force. Now this F equal to mg minus Fd. This is now net force. So now this F equal to ma equal to mg minus Bv. We have put the value. So this A equal to G minus BV upon M. This is the acceleration, and I have told you that this acceleration is like this one. If we draw the graph here, this is the acceleration. This is now velocity. This is now velocity. Then this graph is like this one. At this point, acceleration is equal to 0. A equal to 0. A equal to G. So this V is equal to 0. At this point, now when we are on this one, then A is equal to 0. A is equal to 0. So this V is equal to Vt. Vt the terminal velocity. So now we can have this equation of motion as this is now dv upon dt is equal to g minus vv upon m, or this dv upon g minus bv upon m equal to dt. So now you can see from here that when t equal to 0, this v is equal to 0, and at time t, v equal to now this velocity of object, and this v is not equal to 0, right? So within these limits we have to integrate this equation. Now this integrating. Equation 1, what we have? Integration 0 to v dv upon g minus vv upon m equal to integration 0 to t dt. These are the limits and we have to integrate it. So just after solving, what we get, that this v is equal to mg upon v into 1 minus e to the power minus bt upon m. This is the formula. So this mg upon b, now when t equal to 0, this e to the power minus bt upon m, this is equal to 1. This is equal to 1. Therefore, v equal to 0. And when t equal to infinity, when t tends to infinity, e to the power minus bt upon m tends to 0. So v equal to mg upon b. This is now so much. When this tends to 0, so at t equal to infinity, this will be equal to 0. So now this v equal to mg upon b. So mg upon b, this is now bt, terminal velocity. Terminal velocity. So now we can have, therefore, this v is equal to vt into 1 minus e to the power minus bt upon m. This is now so much. This is the formula for the velocity of the body falling vertically downward. It is velocity of body falling vertically downward in viscous medium. It means that the velocity increases exponentially. It means that velocity of falling body in viscous medium increases exponentially. So now this we can show by the graph. I have told this graph earlier also. Here we have this velocity, here we have the time, here we take the velocity, This is now 0. So what happens? Now this graph is like this. Here this we have the terminal velocity, Vt, terminal velocity. So you can see that this is a constant velocity. It is a constant velocity. Maximum velocity, that is equal to Vt, the terminal velocity. So terminal velocity increases exponentially. This shows that it increases exponentially. So at 0 the velocity is equal to 0. When time increases, that velocity increases and becomes constant after some time. So it will take the time to get the maximum velocity. So this graph shows the variation of this velocity with time, as we have said here in this equation. So this is about the velocity of the body moving vertically downward in the viscous medium. Now we will take the second case. Case 2. Case 2 is what? Velocity of body moving horizontally in viscous medium. Viscous medium. There are so many examples of this kind. Examples. The motorboat ship submarine torpedo, etc. Motorboat always moves on the surface of the water. Ship also moves on the surface of the water. The submarine and torpedo, they move inside the water. So these are the, torpedo is the weapon which act when this is projected inside the water. So these are the examples which the body moves horizontally in the viscous medium. So now we are having the, suppose this is a now let us have, this is a man sitting in this and this is the motorboat. So it is being driven in this direction, and here we will have the drag force Fd. So motorboat is moving like this one. This is now force F. This is now liquid. So when this is moving, then what we have? All these vehicles are driven by the engine. So let force of engine, this is equal to F, and drag force is not drag force. Fd, this is equal to Vv with a minus sign, where B equal to 6 pi eta r. So now this will be driven by this engine, net force F minus Fd is equal to ma. A is the acceleration in this forward direction. So now what happens that if suppose the motorboat is moving and its engine is stopped, then it will not be accelerated, it is retarded, and its velocity decreases and attains a minimum value. After some time it stops. If engine is switched off, that means F equal to 0. Then now this equation will take the shape. This is now your 0 minus Fd equal to ma, or m dv upon dt is equal to minus bv. This is now force F equal to bv. So Fd, this is now bv, this is now so much, and this dv is equal to minus bv upon m into dt. This is not so much. So what happens that when the motorboat is being driven by the engine, its speed increases, and when the engine is stopped, the velocity of the motorboat decreases, and finally it comes to rest. So we have to find that what will be the velocity of the object when the engine is switched off. Similarly, we will study in case of this the ship, submarine, etc. So all these transport means are driven by means of the engine. So now we can have that when t equal to 0, v equal to v0, maximum speed, maximum at time t v equal to the velocity of object or the motorboat. So now what we have, that we will integrate to this one from this is now 0 to v and dv equal to integration 0 to t with a minus sign vv upon m into dt. So after solving this, v is equal to v upon m into e to the power minus vt upon m. v upon m, this is the maximum velocity. When t equal to 0, v equal to v upon m. So what, this is now equal to v naught, maximum velocity. As we have seen here, the v equal to v0. So we have the equation v equal to v0 e to the power minus vt upon m. It means that the velocity of the object decreases exponentially when the engine is switched off. Hence, the velocity of motorboat decreases exponentially when engine is switched off. So now we can have the graph of this one. This we take the time This is now 0. Here we have the velocity. Then this decreases. This shows the variation of this velocity with time. Here we have the velocity v0 when time is equal to 0. So as time increases, the velocity decreases exponentially, as we have shown by this equation. So this we can see that this velocity is the minimum velocity, and then the motorboat will stop after some time. When engine of motorboat is switched off, its velocity decreases exponentially, and finally the motorboat will stop moving. So this is what that this graph is shown by this equation, and this is what the meaning of this one. So this we have seen that similar expression will be in case of the ship, in case of submarine, in case of torpedo. So any kind of object which is moving horizontally on the water surface or inside the water or inside some liquid, then in case of horizontal motion, now this equation is followed. So velocity does not decrease abruptly to 0, but it takes a large time and then it stops. So this is about the velocity of the object moving horizontally in the viscous medium. So thank you very much.